Rising concerns about sustainability are causing researchers and product developers to look for ways to replace old carbon raw materials with new, renewable alternatives like soybeans. The concept is not new. Henry Ford recognized the value of controlling the supply of all materials in manufacturing. He often commented that crops could grow quickly compared to lumber or iron ore, and funded a laboratory to find industrial uses for abundant and sustainable soybeans. In the 1930s, Ford developed a car with soy-based plastic body panels. To drive his vision of fueling industrial growth with agricultural feedstock, he put a bushel of soybeans on the front seat of every car he sold. These days, the beans aren't on the seats, they're in them, in the soy polyols that make urethane foam cushioning soft and comfy. Soy oil derivatives are also in other automotive materials like rubber, plastic, and lubricants. The United Soybean Board, or USB, supports innovative research leading to the development and commercialization of sustainable products containing soy. That's because products containing soy derivatives are reliable and sustainable. Modified soybean oil works as a replacement for petroleum-based feedstocks in polyurethane foam, thermoset plastics, paints and coatings, lubricants, and solvents. And in some cases, soy provides added benefits. For example, soy-based lubricants are less toxic than petroleum-based lubricants and are less likely to catch fire, which is important when you're making dielectric fluids. Besides being slick, soybean grease is also biodegradable. So when soy grease eventually washes off railroad tracks, it flows harmlessly into nearby brush. Soybean meal is also versatile. As the primary component of soybeans, meal is a mainstay in human food products and animal feed, which is by far its biggest use. However, it is also being used in plastics, rubber, synthetic fibers, adhesives, and resins. You'll also find soy in detergents, candles, and personal care products. U.S. soy was setting manufacturing sustainability standards before there were sustainability standards. To help quantify metrics, USB established the Soybean Sustainability Assurance Protocol. It's based on data collected from farmers nationwide who participate in conservation programs. The Sustainability Protocol details everything from water conservation to how much energy is used by farmers to produce and harvest crops, and is a valuable tool that helps manufacturers verify sustainability claims on product labels. These days, most soybean acreage in the U.S. uses conservation tillage, which disturbs the soil less and reduces farmer fuel usage because they make fewer trips through their fields. Unlike fossil carbon sources, soybeans capture carbon dioxide from the atmosphere. And soybeans are renewable, so they provide manufacturers with a sustainable supply source they can rely on. Grown in both hemispheres of the world, there's always a soybean harvest right around the corner. But there's even more to love about the magic bean. A peer-reviewed life cycle assessment study commissioned by USB is helping manufacturers of soy-based products validate production and product sustainability. The report, available free of charge at www.thinksoy.com, verifies that soybeans help lower carbon dioxide emissions during production, lower energy production costs, lower VOC content of products, reduce exposure to toxic chemicals, and provide supply chain sustainability. Soy polyols also show more favorable environmental impact results for acidification, eutrophication, fossil fuel depletion, water intake, criteria air pollutants, total fuel energy, ecotoxicity, and human toxicity. Products made with soy are helping contractors and building owners earn credits toward LEED certification, and have helped companies like Sherwin-Williams and Cargill earn the prestigious President's Green Chemistry Award. Soybeans are versatile too. Their molecular structure and suitable fatty acid profile can be readily modified for many applications, which is why you'll find them in everything, from biodiesel to bath products and wood paneling to paints and stains, polyols, and plastics. Think of all the ways you can make products more sustainable when you think soy. We appreciate the participation of two experts who join us today as we discuss exciting innovations occurring in the bio-based world. We'll look at how they bring products to the marketplace through commercialization and the important sustainability benefits of soy ingredients to manufacturers and consumers. Our first speaker is Thomas Garrison, a PhD research associate at the School of Mechanical and Material Engineering at Washington State University and a member of the American Society of Agricultural and Biological Engineers. Thomas?
So today I'd like to share a little bit about my personal perspective on bio-based polymers and composites. As a materials engineer working with bio-based plastics, I draw heavily on my background in biological engineering as well as chemistry. And today I'll talk briefly in the next few minutes about what brought me into this field of research, how my research contributes to sustainability, and what are some areas for future opportunities that I see developing with bio-based polymers and composites. Now, I first began as a biochemistry student, and my senior year, this was in 2002, I took a course called Biotechnology for Crop Improvement. At this time, we were facing concerns with dwindling petroleum supplies and as well as our foreign dependence on petroleum and fossil fuels. And this class first exposed me to the idea that we could make plastics using bio-based materials. And as a result of this course, I have pursued a career in this ever since. And this is coupled with a desire to develop value-added products that can benefit farmers from agricultural materials. I came from an agricultural background, and I see that my research can benefit American farmers by developing additional revenue streams for them. And finally, I just derive a personal satisfaction from being able to tackle real-world problems and how we can utilize these underutilized resources and make products that will benefit the environment. So for the last several years, my research has focused on petroleum-based, vegetable oil-based polyurethane coatings. And these are waterborne materials. And so by replacing the petroleum-based solvents with water as the solvent, we're reducing the volatile organic compounds, or VOCs, that are given off that damage the environment and also pose as health risks to both the producers as well as the end consumers. And by substituting vegetable oil-based polyols for the petroleum-based polyols, we're reducing our dependence on petroleum and making these sustainable green polyurethane coatings. Now, these materials can be used in a wide number of applications, including inks and paints, textile coatings, and paper coatings. Now, before I talk about where I see future opportunities for bio-based polymers, I want to briefly mention a few areas where bio-based polymers are already widely used. Many traditional coating materials use vegetable oils such as the alkyl resins in their in traditional paints. We also see many thermoset plastics, such as the foam seat cushions that Mike mentioned earlier that are going into the Ford Motor Company products that are made from vegetable oils. So thermosets cannot be recycled, and they're due to the amount of cross-linking from these materials. Vegetable oils are natural candidates for making thermoset plastics. And finally, we see many examples of fiber-reinforced composites. Natural fibers are polymers, and the biggest example are wood-based composites, and we'll talk more about that later in the webinar. So what are some areas where I see they're developing for bio-based polymers and composites in the future? Well, the first thing is that we need new formulation strategies for working with bio-based polymers. Bio-based polymers and these polyols contain different functional groups in the chemical structure compared to the traditional materials that have been derived from petroleum. And as a result, we need new compatibilizers and stabilizers to work with these chemicals in the formulations. Now, there's no magic difference in the organic chemistry. The organic chemistry for petroleum-based materials is the same organic chemistry that occurs with bio-based materials. We just need new strategies for formulating with these materials. Bio-based thermoplastics has not really been developed yet compared to the thermosets. Now, the thermoplastics are going to be examples like your plastic bags or your Coke bottles, things that can be recycled. And so if we can develop cost-effective bio-based thermoplastics, they'll have a much greater impact on the consumer market. And there's currently work being done on this, both in academia as well as in industry. Now, another area, I mentioned already that bio-based fiber-reinforced composites are already widely used. However, the matrices, or the resins and glues and adhesives that bind those fibers together is a candidate for being made from bio-based materials. And we'll also hear about this later. But recently, I was a co-author on a critical review in Green Chemistry, and the reference is given there, where we examined a number of different bio-based resins that are being used for composite applications. And if we can make bio-based matrices coupled with the fibers, then we can have 100% bio composites. Now, finally, another area that we're going to see huge development in is the development of bio-based drop-in monomers and chemicals. I've already mentioned that new formulation strategies are going to be needed for using these novel bio-based polymers. However, another strategy is to take the biomass and convert it into existing chemicals that are already used in the polymer industry. Now, the United States Department of Energy recently had a call for proposals for making renewable carbon fibers from lignocellulose by converting the lignocellulose into acrylonitrile. Acrylonitrile is then polymerized and into polyacrylonitrile and then carbonized into carbon fibers. And so the Department of Energy is looking at funding research into how we can make acrylonitrile from lignocellulose. So some final thoughts about bio-based polymers and composites. High performance is critical. The consumers and end users will not accept materials that are bio or green unless they meet the same performance characteristics of their existing products. Additionally, most consumers are not willing to pay a premium for bio or green products. And so not only do they have to meet the same standards and the same performance criteria, but they have to come in at the same cost or even cheaper. And lastly, the techno-economics and life cycle analysis of these bio-based materials has to be beneficial in both regards. You can have a green product that is very sustainable, but if it costs too much, it'll never see the market. And conversely, there can be bio-based materials that, in order to convert them into a usable form, require more energy or use harsher chemicals than the existing products, and so can actually cause more damage to the environment. And so when we're making these bio-based polymers, we have to make them in such a way that it is still sustainable for the environment.
Now let's move on to Don Scott, who leads sustainability efforts for the National Biodiesel Board and who's on the cutting edge of research and more that he'll share today. Don?
Thanks, Mike. As Mike introduced, this is Don Scott with the National Biodiesel Board, and I want to talk briefly, just very basic, about what biodiesel is, but then I want to talk more about the life cycle analysis and how we quantify the benefits of biodiesel. And then I want to talk more generally about the carbon cycle, because the same benefits that biodiesel delivers really applies in general to most bio-based products, as they all have the same role in recycling some fundamental elements and using natural cycles and using organisms to do that. So beginning very, very briefly, and just in case you haven't heard of biodiesel, biodiesel is a renewable substitute for diesel fuel made from vegetable oils like soybean oil or animal fats. And the National Biodiesel Board is a nonprofit organization. I work for the National Biodiesel Board. We have members who produce biodiesel and feedstocks all across the country. And we are a coordinating body for research with the goal to develop a commercial biodiesel industry. It was our goal that we could make it a possibility for consumers to choose bio-based biodiesel as an alternative to petroleum diesel fuel. And by building that commercial industry, we seek to improve the economics of local communities, increasing domestic jobs well beyond the ag sector. It's not just about delivering jobs for farmers making feedstock, and it's not just about jobs for people that are producing biofuel. It's about keeping our domestic funds in our local communities instead of sending our money overseas to import petroleum. So in doing that, we can reduce the outflow of American dollars for import, and we can shift away from the sole reliance on the diminishing resource of fossil fuels. And at the same time, while we can do that, we can also reduce environmental impacts. We can reduce harmful vehicle emissions. We can reduce net CO2 and other greenhouse gases, and we can reduce threats to water and ecology. So biodiesel currently is in commercial production all across the United States, with a lot of production happening in the Midwest, but with also significant amounts of production happening everywhere from New York to California, all using a variety of feedstocks. And some of the reasons that we're able to be a commercial success is because we have the feedstock availability, we have the production capacity to produce fuel right here in the United States, and we offer a product that performs seamlessly with conventional diesel fuel. All of the major medium and heavy-duty truck manufacturers approve blends up to 20% biodiesel in diesel fuel, and it yields the same kind of horsepower, torque, performance, and fuel economy as conventional diesel fuel. In addition to that, we actually offer a few performance benefits, such as low sulfur, enhanced lubricity, and high cetane. But the real benefit really does come from the environmental benefits, and in particularly the life cycle carbon reduction. The environmental benefits of biodiesel are multiple. It will clean up the tailpipe exhaust from a diesel vehicle, particularly in an older diesel engine. Will run cleaner on biodiesel. Biodiesel itself is non-toxic and biodegradable, so if you were to spill biodiesel in the environment, you're at a lower risk to water quality and the environment. And in the production of biodiesel, we're reducing impacts because producing biodiesel compared to producing petroleum diesel produces 79% less wastewater and 96% less hazardous waste production. But the real environmental benefits I want to talk about are the energy efficiency. I want to talk about the life cycle reduction of CO2 and other greenhouse gases. And a lot of what I say is true for biodiesel is true for other bio-based materials, and particularly for biodiesel because we're using it as a source of energy. That liquid fuel is essentially stored solar energy, and particularly when we're using plants or using natural oils as the feedstock for our liquid solar energy. Plants have evolved to store solar energy in oils, and an annual crop like soybeans is perfectly suited to do just that. If you think about it, an annual crop that the plant grows for a season and then dies and the seeds overwinter, in order for that species to continue, a new plant has to grow next year from the seed. The seed contains all of the genetic material, and so those plants have evolved to invest a source of energy to ensure the survival of that seed, so that seed can grow into a plant. And so that's, the oil inside a soybean is a little natural fuel tank that the plant has evolved to take solar energy and store it in that liquid fuel so that the plant can propagate in the next season. And so we're able to take advantage of that natural storage device. And it's actually very simple, very straightforward when you use a vegetable oil to make a biofuel, because nature has already done a lot of the assembling of that long carbon chain. So that natural vegetable oil looks very similar to our conventional petroleum fuels. It's possible to make biofuels from sugars and starches and even cellulosic material, but it requires more conversion on the back end. Whereas with biodiesel and with vegetable oils, we're letting nature do most of that work, storing solar energy in that liquid fuel. And so there's several ways that biodiesel plays into these natural cycles, and one is just that storage of liquid solar energy. The other is the elements that make up that liquid fuel source. Biofuels, just like our conventional petroleum fuels, are hydrocarbons. They're made of hydrogen, carbon, and oxygen. And the benefit of biofuels like biodiesel is that those elements are recycled from the atmosphere. Plants take solar energy and they take hydrogen, carbon, and oxygen out of the atmosphere, and they reassemble them into hydrocarbons as an energy storage device. And when we burn vegetable oil or biodiesel, we re-release the hydrogen, carbon, and oxygen back to the atmosphere. And had we not intervened and harvested energy from that product or used it for a bio-based material, that hydrogen, carbon, and oxygen generally reverts back to the atmosphere regardless of what we do. When plants die and decompose, those elements go back to the atmosphere, either in the form of CO2 or sometimes in the form of methane. So whether that happens in a pile of compost in the floor of a forest or in the stomach of an animal that's eaten that plant material, those elements are eventually broken down and returned back to the atmosphere. So the biodiesel is participating in this same cycle. And Mike discussed earlier that soybeans are 80% protein meal and 20% oil. And that's another fact of nature. The plant has evolved to provide that ratio of meal to oil. It doesn't matter how many soybeans you grow or how many soybeans you crush, you typically always get that ratio of meal to oil. And what's happened is that because we have a demand for protein, primarily for livestock feed, We're producing soybeans to meet that demand. But in our world, in the economic sense, the demand for meal and oil is not at that same 80-20 or 5-to-1 ratio. Mike mentioned that we have 30% of the oil that's used for bio-based products. So that's the opportunity for biodiesel and other bio-based products to use that oil that's being co-produced along with the protein meal and sort of reestablish that balance in the supply and demand, because nature has already given us this fixed ratio of oil and meal. And in the United States, we're actually declining in the per capita use of vegetable oil. So as long as we maintain a steady demand for protein, in the future we're likely to see the same or even larger availability of vegetable oils. So, and I talked about how biodiesel uses this natural cycle, and we're recycling carbon that exists either in the atmosphere or in plants and living or recently living organisms. And if we were to just use renewable energy and just use biodiesel in the production, we would have a net neutral impact on carbon in the atmosphere or the greenhouse gas effect. But we do use petroleum as our baseline fuel. We're still using some petroleum diesel fuel in trucks and tractors that produce soybeans and transport them to processing. We still use natural gas and coal-fired electricity to process soybeans and produce biodiesel. So in our life cycle analysis, we include all those emissions from the fossil fuel that we use, and it's by doing that math, we calculate the renewable energy ratio for biodiesel. It proves for every unit of fossil energy we put into that process, we're getting 5.5 units of usable renewable energy out, and that corresponds to a greenhouse gas reduction on the order of 85% relative to petroleum diesel. So for every gallon of biodiesel we produce and use, we're offsetting a gallon of petroleum diesel that we would have to extract from the crust of the earth. So we're reducing greenhouse gases by approximately 85% with every gallon of biodiesel we use. And so with that, I'd like to step back and talk a little bit more about the carbon cycle in general as it applies to biofuels and bio-based products. And the reason that we have an issue with greenhouse gases is that we are changing the atmospheric level of CO2 in the atmosphere. We are causing that level of CO2 to rise. And while in a human time scale, the level of CO2 in the atmosphere has been relatively constant or in an equilibrium, it hasn't always been exactly the same. If you go back 500 million years, there was 20 times as much CO2 in the atmosphere. The Earth was a much different place. It didn't look the way it does today. Life as we know it did not exist. But over the course of hundreds of millions of years, life evolved in organisms, whether plants or animals. They took CO2 out of the atmosphere, incorporated into their bodies. That alone did not really disrupt that equilibrium, because as plants die and decompose, that carbon also goes back to the atmosphere. But there's another thing happening at the same time, and that is a much slower process, that geologically, some of this carbon that's converted to a solid form by organisms, some of it can slowly find its way into the geology or into the bedrock of the Earth. And that's what's, over a long, long period of time, that's what's changed the atmospheric level of CO2 from being 20 times greater than it is today 500 million years ago. But in a couple centuries ago, we learned that we could utilize the energy in those deposited, those carbon deposits that we know as fossil fuels. The coal, petroleum, and natural gas, we learned that we could make money by extracting those and harvesting that energy. So in little more than a century, we've been reversing that process as fast as we can, taking that permanent fossilized carbon out of the crust of the Earth and also putting that into the atmosphere when we burn it. And the issue with that is that we've been overwhelming the Earth's natural abilities to maintain that balance. If we simply look at how much fossil carbon we pull out of the crust of the earth every year in fossil fuels, it's on the order of 7.3 billion tons. Now, at the same time, all the plants on Earth are growing and trying to use that carbon from the atmosphere. Every tree on the surface of the earth and every blade of grass combined can only use about 2.2 billion tons of carbon every year. So the plants alone can't keep up with the amount of carbon we're using in fossil fuels. Now, the oceans are part of the balance as well. Oceans are absorbing these high levels of CO2. It's not particularly good for them. It's turning the oceans acidic, but nevertheless, the oceans can absorb about 1.8 billion tons of carbon every year. And the geologic process that formally converts carbon into bedrock is also going on. It's just very, very slow. So less than 1% of the fossil carbon we emit every year manages to find its way back into permanent rocks and sediment. So if you add all these together, all these things are happening at the same time, we're still adding over 3 billion tons of carbon to the atmosphere every year. And so all of the plants on the surface of the earth are already doing everything they can to reabsorb this carbon. The only way to set this equilibrium back in place is to reduce the amount of fossilized carbon that we're taking out of the crust of the earth. And so that's where biofuels and bio-based products in general play in, is that there is lots of carbon on the surface of the earth in the atmosphere that's being recycled by plants, and we can use that to produce products and to harvest energy without tapping into the fossilized carbon that's causing the imbalance in our greenhouse gases. And so that's really the basics that I wanted to share that sort of tie the story together to emphasize why biofuels and biodiesel are important for us today, and why bio-based products in general can also play a role. Before I close, I will mention that while we produced record amounts of biodiesel last year, we produced 1.8 billion gallons of biomass-based diesel. About half of that was produced from soybean oil. Soybean oil continues to be our largest single feedstock. We're growing because the amount of soybean oil available for biodiesel continues to grow, and we're also growing because we continue to diversify to other forms of vegetable oil and animal fats that are available.